Electricians, I'm going to walk you through a licensing exam question that you very well might see on your licensing exam. Again, walking you through using the 2026 NEC. Our question reads, a motor control center serves the following three-phase 460-volt motors. We have one 100 horsepower motor, six 15 horsepower motors, and two 7.5 horsepower motors. Okay, obviously, we're going to have to turn to Article 430 to find this answer, but ultimately the question is asking us, what is the minimum ampacity of the feeder? It's not asking for the feeder overcurrent protection device, it's asking for the ampacity of the feeder conductors. Okay, so let's open to Article 430. Again, I'm going to be reading through the 2026 NEC, and I'm doing this raw, guys. I'm not doing this prepared, okay? So again, we're doing circuit conductors, okay, feeder conductors. So we're going to be reading specifically out of part 2. Okay, I'm going to zoom in for you so you can read along with me. So motor circuit conductors, this is not specific to branch circuits. This is also for feeders. So my answer is in part 2 somewhere. So now I'm going to read the bold headings. Part 1 says general. Part 2 says single motors. Are we dealing with a single motor? No, right? These are multiple motors. So I'm going to skip all the A's, B's, C's, 1, 2's, and 3's, right? 3's. Okay, moving on. We're going to see 430.23 says wound rotor secondary. Our question says nothing about that. So continuing, making sure you can see this, 430.24 says several motors and and other loads. Okay, so this is where I'm going to find my answer in here. Say, let's read it. It says conductors supplying, let's use my pen so you can follow along with me. Conductors supplying several motors or a motor and other loads shall have an ampacity not less than the sum of each of the following. So I'm going to read these 4, okay, and get ampacities for all 4 of these and then add them together. Based on that ampacity, I have to size and select my wire. So the first one says 125% of the full load current rating of the highest rated motor as determined by 430.6a. So I'll probably explain that code article to you, but I do encourage you to read that on your own time. 2 says the sum of the full load current ratings of all other motors in the group as determined by 430.6a. So again, it's important to understand 430.6a. 3 says 100% of the non-continuous non-motor load. Our question doesn't have a non-continuous non-motor load, so we're going to ignore 3 for this question. 4 says 125% of the continuous non-motor load. Our question doesn't have that. So for this question, we're skipping 3 and 4, but we do need to get an ampacity for 1 and 2 and then add them together. So before we do that, let me explain 430.6a. Again, I encourage you to read that on your own time, but 430.6a basically says when we're sizing motor conductors and motor branch circuit, short circuit ground fault protection, and motor feeder short circuit ground fault protection, we're going to size it based on the ampacities that the code book gives us. The code book in the back of Article 430 gives us the full load currents. It gives us ampacities. So again, for conductors, branch circuit, and feeder short circuit ground fault protection, we use that ampacity. 430.6a also says that for motor overload protection and very specific types of motors, we will use the ampacity written on the nameplate of the motor. It's very important to understand that distinction. So for this question, we're going to use the ampacities that the codebook gives us in the back of Article 430. So let me do that. Go to the back of Article 430. Hopefully I have a piece of paper. I do. So I'm going to have to write down some ampacities here, okay? So going here, as we can see, 430.250 tells us the full load currents for 3-phase AC motors. So our first motor in question says a 100 horsepower. So that's right here. I say 100 horsepower. That's my row. Now my column is 460 volts. So 124 amps is what I'm going to have for this 100 horsepower motor is 124 amps. Most likely that's going to be my largest motor, but let's continue just in case. We have 6 15 horsepower. So that's 21 amps. What did I say? 15 horsepower? 15 horsepower, and it's important to write down that there's 6 of them. And what did I say? What was it? 15 horsepower, so 21 amps. Sorry if my paper's all over the place. And then we have 2 7.5 horsepower. I'm writing very quickly because I'm running out of time in this video. So 7.5, 460 volt is 11. So let's go, now that I have all my full load currents for all of these motors, let's go back to that code article that specified what we need to do here. So again, number 1 says 125% of the full load current rating of the highest rated motor. What's the highest rated motor? That's my 124. So 124 multiplied by 1.25. Let me get a calculator out. is, so 124 times 1.25 is 155 amps. So that's covers number one, 125% of the largest motor, the full load current of the largest motor, which again is specifically the ampacities in the code book. And then 2 says the sum of the full load current ratings of all other motors. Okay, so let me add 6 21s and 2 11s together. That will get me the ampacity for number 2, and then I'm going to add that 155 amps to that number. So let's do that, right? So I have 6. Let me get my calculator. Come on, where's my mouse? So 6 times, oh come on. So 6 times 21. Okay, so that is in total 126 amps, and then let's go 2 times 11 is 22, so I know how to do that, right? 126 plus 22 gives me 148. So again, this complies with 1, this complies with 2, and now I need to add those together to be code compliant. So 148 plus 155 gives me an ampacity of 303 amps. So my conductors for this feeder has to be at least 303 amps. Looking at my question, it looks like C is going to be my final answer. This is nice because it's exactly 303, so I am confident that this is my answer. But again, I want to explain what I did here. So 1 is 125% of my largest motor. So my largest motor was 124, took 125% of that, and so number 1 gives me 155 amps. So 1 is 155. 2 says the sum of the full load currents of all the other motors. So again, I took 6 21s. Okay, there were 6 15 horsepower motors. Each one is rated at 21, so 6 times 21 gave me 126 amps, and then there was 2 11 amp motors, so 22. Adding those together gave me 148. Adding those together, 303. That's going to be my final answer. This was a doozy. This is one that you will see on your licensing exam, journeyman's or master's, so it's important that you know how to do it. In my book, A Comprehensive Guide, Chapter 5 talks about sizing motors. If you want to master motors, which is a hot topic and a difficult topic, go to the TikTok shop, grab yourself a copy of this book, A Comprehensive Guide. Hopefully you enjoyed this video. If you learned something, comment down below. Yeah, I'll see you guys on the next one. Thanks.